The evidence for evolution that we'll discuss in this video comes from the fossil record, selective breeding, and from homologous structures. To start with, fossils are the preserved remains of organisms that lived a long time ago. They're formed from the hard parts of those organisms, for example, the shells, the bones, or the wood. Paleontology involves the study of fossils, and paleontologists study these fossils to determine the organism's evolution and interactions with each other and their environments. Although the fossil record is incomplete and fossils are rare, it is possible to show how modern plants and animals might have evolved from previous species. For example, the fossil sequence for the modern horse, Equus, shows that over time the horses have developed single-toed hooves, longer legs and longer faces. While we can't expressly say that this species evolved into that species, we can say that the organisms from which these fossils were obtained appear to be related and probably share a common ancestor. However, it is possible that other fossils could have existed that just haven't been found yet. That said, many living organisms today have no identical form in the fossil record. This evidence from the fossil record supports the idea that life on Earth is constantly changing and that this occurs over millions of years. Selective breeding or artificial selection is when plants and animals with favourable characteristics are bred to increase their numbers within a population. For example, farmers who breed cows might choose favourable characteristics such as those producing the highest quality milk or meat or those producing the highest yield in milk. The driving force in this case, as also with the breeding of domesticated dogs like this Great Dane and this Chihuahua, is absolutely human intervention and human choice. However, through selective breeding, we can see that it is possible to produce species that have characteristics that didn't exist before. You might recently have seen one of these golden doodles, the result of breeding a golden retriever with a poodle. So although selective breeding is not the driving force for evolution in natural ecosystems, it does demonstrate that species can change over time and, as I said, exhibit unique characteristics which did not exist before. Finally, homologous structures are anatomical features that are similar in shape and function but exist in different species. For example, when we look at the vertebrate pentadactyl limb, we see that the basic shape and position of the ulnar, radius, and carpal bones is similar in the human, dog, bird, and whale. The evidence from homologous structures such as the pentadactyl limb suggests that those species are closely related and share a common ancestor.